IoT Unplugged, where we talk to industry leaders, innovators, and major players in the Internet of Things, bringing you the best and latest insights. Tune in to learn more. In this episode, I'm joined by Stefan Hoppe, President and Executive Director of the OPC Foundation, where we discuss the OPCUA standard, the highlights, and the importance of collaborative work. Hi, Stefan. Thank you for joining me today on the IoT Unplugged podcast.
Thank you so much for having me.
So to start us off, could you quickly introduce yourself and talk a little bit about who you are?
Absolutely. I'm Stefan Hoppe. I'm in the business since 30 years, starting as a software engineer at Beckhoff Automation. And the first 10 years I was a software developer on the previous OPC standard, what we call today OPC Classic. Then I was for 10-year product manager. And since 10 years, I'm spending my full time for the OPC Foundation. That's it.
Great. And so who is the OPC Foundation and what do you do at the foundation?
The OPC Foundation is an international non-profit organization. It's the home of industrial interoperability. And as an organization, we are responsible to develop and maintain the OPCUA standard, which, by the way, is also an IEC standard. And, the OPC standard is an interoperability standard for the secure, reliable exchange of information in the industrial automation space, mostly, but we will talk about later on. We are growing out of that space, which is scaling from the small sensor and all seamless flow of information among the devices through the cloud. And it's independent from operating system, from the platform, from vendors, from the market. That's OPCUA.
Yeah, and we'll be talking a little bit more about industrial interoperability and the standard and kind of the direction in which it's going. But before we get onto that, why don't we talk a little bit about the collaboration that you do and some of the examples of collaborations that you have done in the past?
There are a lot of collaborations. We are partnering with about 60, 70 partners. And I have to explain now a little bit what is OPCUA and a little bit on technology. OPCUA is a modeling language where you can describe things, your pump, your robot, whatever. Also software services. It's not only for physical assets. And on top of that, once you have done that, then various transport mechanisms and integrated security are available out of the box. But to describe something, you need to agree on semantic, that everybody is aware what does it mean. So if we both if I point to something and say, hey, look at this great Jaguar, maybe I, as an engineer, am more looking to the car and you maybe mean the animal, right? So companies have to come together and agree on the meaning of variables and actions. And this is what we exactly do with partners. So the OPC Foundation is describing how to exchange information. And our partner companies, because they are the specialists in different domains, they describe the what is to be exchanged. And so, for example, the VDMA, European largest machine association, builder association, made a huge number. I believe, meanwhile, it's over 100 on so-called OPC companion specs. So they have the robotic group and the weighing group and 40 of these groups. But we also cooperated with the IDTA. They are doing semantic interoperability for IT, cloud, digital twins. But we also cooperate with security agencies like the BSI from Germany, ANSI from France, Homeland Security USA, and they all reviewed OPCUA. So we are cooperating with a lot of other associations to stay in contact, and that's what I truly believe on is really critical important, because no association in the world can solve the challenges on their own. That's not working, and we need to be open-minded and cooperate. Yeah.
Mm-hmm. You like the standard needs to be open, which I think is quite a nice point to make.
Yep.
So you earlier, Stefan, you mentioned industrial automation has been a focus, but it's something you're branching out into other areas. So could you talk a little bit about the OPCUA standard in how it's evolved over time and some of the highlights?
Yeah, I mentioned that I have been the developer on the OPC Classic, which has been the first step, but OPCUA is the real interoperability standard now, super successful. Interesting, the main everything started in 2003 to 2006. Within just 3 years, not we, I was not part of that. The super smart people designed the core architecture of the standard. That's really crazy. And within the last 18 years till today, 2024, there have been 5 major updates, but we never lost backward compatibility. That's really critically important for the industry to invest in a standard and it's stable over the years. There are so many highlights, but I can mention one of these extensions to show you what kind of extensions I mean. For example, in the year 2018, we extended our communication pattern, which was client server till there, to pub/sub, which is a different communication pattern. It's a little bit more broadcast, one to many or many to one. And this technology is now allowing that we have these standardized OPCUA messages, what I explained before, where people agreed on the semantic. So we have a standardized message, and now we are able to also exchange these kind of messages via UDP for the field, to have super quick communication between devices as it's in the field, horizontal, but also over MQTT, because a lot of people believe MQTT is a de facto standard for cloud connectivity. That's true. We love MQTT. It is not, should I go OPCUA or MQTT? Instead, MQTT is missing a definition of the payload. So it's never interoperable. And we defined OPCUA over MQTT. And that means you have standardized messages to the cloud. So in simpler words, not non-technical, we designed the so-called USB connector to connect physical assets, the robot, the weighing machine, the pump, the motor, directly to cloud systems like AWS dashboards, Microsoft Azure dashboards. It simplifies the connection, and that's, I believe, super, super great. Yeah.
So taking into account everything you've just mentioned, could you share some real-world implementations of the standard? What have you seen the industry use it for?
Well, as mentioned, the specification has been finalized, and version 1.0 of OPCUA has been published in 2006. I was the proud person providing the world first OPCUA product, at that time integrated in a back-off PLC 2007. 2008, we have the first worldwide success story, the public one. It is connecting a wind turbine park in the German North Sea to the land IT. From that, you see, if you go to the OPC Foundation web, you see under material success stories, super, super fascinating success stories. I just mentioned a couple of them to show that it's completely independent from the region in the world and different markets. So let's start in Norway, in the process industry. Company Equinor, for example, connected more than 1 million data point to Microsoft Azure. So the OPCUA have been selected as a connectivity technology in their Johan Sverdrup oil and gas drilling facilities. Remember, just this platform is providing 30% of the whole energy what Norway is getting. And OPCUA has been on the central part of the digitalization strategy since 2015. But we can also switch to discrete manufacturing, and let's go to France. The Renault Group has connected over 15,000 assets in their factories with OPCUA to their IT. They call it the Renault Group Metaverse, where they have digital twins of everything. They do it, by the way, in cooperation with Google Cloud. And so here you also see it's not only different regions, it's also different cloud providers. Energy. I'm super proud that a company, their name is Cartec, and with the help of another company, Predictor, also from Norway, they connected the world's largest power plant. The grid has been connected 2019. It's producing over 930 gigawatt hours. So that's really crazy. They are collecting over 100,000 data points per second, right? And maybe two last, because they were the current, latest, greatest success stories. Philip Morris, tobacco industry, implemented, and that's also interesting. It's the world first success story where a big end user is showing the result of these domain specific information models. So they started somehow 2016 bringing all their competitors to a table. That's really one of the success stories. And key factors, you cannot do a standard just on your own. If you want to do an international standard, you have to invite your partners on the market, your competitors, you need to invite your suppliers, and then agree on something. Only if you have agreement in a common sense, then it's seen as we all are fathers of this new standard, we all support it. If somebody tries, just I'm the biggest on the market, I try to establish my own standard as a world standard, it's always difficult. So Philip Morris has partnered with all of their other competitors, and they wrote this UA for tobacco companion spec. And now they report about their challenges introducing this into the industry. It's really fascinating story. You can read more on that on the OPC web. And maybe the last one, and you see me already smiling. It's so unexpected, and so we are so proud. OPCUA was integrated into a civil rocket. So from Airbus. So they are shooting a civil rocket into the space to have zero gravity for a while, and then they do some experiments. And all the connectivity from that civil rocket down to the Earth is done via OPCUA. So you see it's a super robust, reliable technology, and we will grow much more. You see it from all other areas of the world. Big electric cars companies from China are using OPCUA in their facilities up and down. Procter & Gamble in US is using it, and they talk public about that. So there are a lot of stories. I mean, the technology is 18 years on the market. It is. We are not starting from scratch here. Yeah.
Yeah, I mean, it must be quite both eye-opening and rewarding to see kind of the variety of implementations you've just highlighted.
Yeah.
So what do you just said it's been on the market for 18 years. What do you kind of anticipate for the future of the standard?
I believe OPCUA will grow into all areas. It will continue growing inside the core industrial automation area. I mentioned it's not only discrete manufacturing, it's also process industry, it's energy. We are doing a lot right now in energy, in the renewable energies. But it is also growing to outside areas of the core automation business. For example, years ago, even the commercial big kitchen equipment companies integrated OPCUA. So you have industrial coffee machine and a frying system with OPCUA. Or right now, I like that the members of the European Union for the vending and coffee snack machines have decided to integrate and solve their interoperability challenges with OPCUA. Just to give you a super short intro, I mean, you see these kind of vending and coffee and snack machines wherever you go in your private life, right? You go just to a city downtown and you see them everywhere. And what I have not been aware of, inside these machines, you have components from different suppliers for the cooling, for the handling of the material, for the cash part, and so on. And all these components from different suppliers have somehow to work together. And the vending machine to the outside world, to the cloud, also should talk in a standardized way. So they started already, and we will see much more of that in the future. And I believe OPC will have a super big grow into the IT world, like to the cloud world, but also inside cloud, because OPCUA is not just a last mile to communicate to physical assets. It is solving interoperability, and this challenge you also have between two cloud applications. You have two digital twins, and so how should they communicate to each other? And guess what? You need to agree on the data. You need to data model. Then you need standardized transport of information, and you need integrated security. And OPCUA has already solutions for that because, for example, REST interfaces or file transfer has also been integrated into OPCUA since 2013, 16. I have to look that up in our history wall. But very early. Maybe we did a bad marketing on that, but now we show the IT world, hey, you can connect two digital twins, or you can connect, you can let the information flow from the machine, first of all, to the digital twin into the cloud, but then exchange information between two digital twins or the metaverse, or think about the digital product passport, which is European law. The first digital product passport, which is European law already, is the battery passport, which has to be available in 2027. And in the world of standardization, that's a super short time frame. And we already have shown a digital product passport together with the company Huawei from China. And we used the semantic of the battery, which has been designed by a Berlin team. They have been funded also by the European Union. And for us, it took just 4 hours to integrate the 107 parameters from Berlin, and then Huawei put in all their parameters. So yeah, our technology is proven, and we can just start. Yeah.
Great. Well, thank you for that overview, Stefan. It was really interesting. So we've spoken about how OPCUA as a standard addresses interoperability, but I'd be curious to get your thoughts on what you think the main barriers to interoperability and open communications are currently.
I think I mentioned that the technology is available. All big puzzle pieces, all big building blocks are available. I personally believe the main barrier is sitting in front of the computer. It's us human beings, and because mentality in the world is we like to reinvent the wheel. The standard is not made by me, or I have been late on the market, so now I want to create something new and be the first on something new, and then you have a lot of islands of something which is not growing together. So meanwhile, OPCUA is the biggest ecosystem of industrial interoperability. And ecosystems are important. This is where people invest money. And this is where you have open source, you have toolkits for RAM starts, and where you find partners. And once you are in this big ecosystem, it's so easy, specifically for small and medium companies, to be part of a larger ecosystem, right? For example, SAP and the cloud suppliers will not implement every small solution on the market, but they have integrated and implemented OPCUA. So whoever has OPCUA, you are immediately connected to SAP and Alibaba Cloud and IBM and Google Cloud and Microsoft Azure, AWS, and so on, right? Yeah.
Well, I mean, it goes to show what can be achieved with the power of collaboration, as you've continually stressed during the podcast.
Yeah, absolutely. And I mean, having a great idea is nice, but getting it down to earth is much more complicated. And educating the world and convincing the world, hey, let's invest here and not reinvent the wheel 1,000 times. That's also my biggest job to do, right?
Sure. So with regards to having greater interoperability between different equipment, machines, robots, cybersecurity obviously becomes more of a concern if it's not already a major concern for those operating in industrial automation. So how are you at the foundation thinking about cybersecurity and addressing concerns, particularly when it comes to mission critical applications?
It is the most important topic. And you know what? Even I'm so talking in a passionate way about interoperability. If it's not secure, interoperability has no value. So that's topic number one, and that's why OPCUA has been designed from begin with security by design. It was always from the begin the part, and so it's not like when I started 30 years ago, and you tried to exchange information with another company, it was let's check what protocol are you supporting, or I also support Modbus, for example, and then on a piece of paper you agreed on the data you are exchanging. And so this never is scaling to other projects because it was individual made as a contract between two individuals. OPC is different. We first model data and then transport and security is built in. So which means security is not only on the transport exchange level to exchange data via TCP, UDP, MQTT or REST or whatever. It is also who is allowed to see and browse and access what kind of data. And because of the relevance of OPCUA for the industry, we have been super proud that cyber security departments from Germany, France, United States contacted us, and they have reviewed both the specifications and the open source offerings what we have. And obviously they found something, and we fixed everything. And that's what we continuously do. But because all specs are available for everybody, nobody has to pay for that once they are released. And also the open source is available for everybody. We are not selling a black box where we just tell you, please trust us. It is open, transparent, and that's how we try to convince people from this is the best standard. And that's what we also learn from whoever from the security agents. That's it. And by the way, you can also find their press releases public on the web on this.
I think the statement you made about interoperability having no value without security is quite a powerful one, and definitely will stick in my brain. So before we finish, Stefan, why don't we talk about some of the key initiatives and projects that the foundation is involved in looking to 2025?
Yeah, absolutely. I mean, there are a lot, but if I try to put on a lot of filters and then say what I believe is happening, let's start with the field, with the OT world. I mentioned already this field level communication group, what we started in 2018. They are standardizing that machines who are in a factory, that they're able to exchange information horizontally on a configured way. Nobody has to implement it. It is just configuration. So, and this standardization effort is finalized. And this year we prepared our OPC lab to be able to certify this, because certification is mandatory for this level. And in 2025, I'm personally expecting the first products being available from all these 25 big international companies supporting this initiative. But I also mentioned we are growing into the cloud, IT edge cloud connectivity. So a lot of information is bubbling up from the factories and the plants up to the IT level to do predictive maintenance, to have digital twins, to use artificial intelligence to get more insights of your plant. And right now we made an alignment with the IDTA Association about the so-called asset administration shell and the digital product passport, which I mentioned before with the battery. And here also we will have a collaboration, or we have a collaboration, that the IDTA and the AAS people will provide the semantic, and it will be based on the OPCUA modeling language. So if you have described once whatever topics, then you find the same information with the same data types also in the IT world, and that makes sense, obviously. And so, yeah, in general, I believe that the OPCUA modeling language will grow a lot more into the IT world. This is also what I learned when I visited here the Renault group, that they have used OPCUA up into their own metaverse, and they got so many insights. The first time they're able to measure the success, how was a factory running before we had all these digital information? How is it now? How many stops of production could we avoid, and so what does it mean in money and so on. So that's what I believe are the major topics for 2025. Yeah.
Great, lots to look forward to. So thanks, Stefan, for taking the time to chat with me and share some of the information to our listeners.
It's a pleasure for me. Thank you so much for having me.